Hey guys, in this video we're going to look at solving polynomials by using the sum and difference of cubes. Alrighty, so I have this kind of highlighted box here, and this will help us to factor our cubic functions. Okay, so you're used to seeing a quadratic where, x times x is x squared, and what multiplies to get 16 but adds to get 8, whatever the case may be. Here they give us a formula to use, a guide. So all we need to do is kind of figure out what our a and b equals, then we can plug it in. So here's my first example, x cubed minus 8. Well, it's in the form of a difference, right? It's being subtracted, so we're going to use this formula here. My a is my first term, and we actually need to take the cube root of it first. Okay, I need to get a by itself. So what's the cube root of x cubed? The cube root of x cubed. Well, basically these two things cancel each other out. So I'm left with just x. And for b, what is the cube root of 8? What times what times what equals 8? Well, that's 2. Okay, so I have my a and I have my b. Now I can plug those things into our equation for difference. Alright, so we have x minus 2 times the quantity x squared plus 2x plus 4. Again, our goal is to solve for this polynomial. So what I'm going to do is take both pieces and set it equal to 0. But I want to make sure I'm factored into my lowest terms first. So I kind of take a look at this, and I see I can't really do anything else with it. So I can go ahead and set that equal to 0 right away. And we have x equals 2. So there's one solution to our polynomial. It's a cubic function, so there are 3 possible solutions, right? Whether it be real or imaginary, there are going to be 3 solutions. So we need to take a look at the second part of the equation and ask yourself, can it be factored? So I have x squared plus 2x plus 4. Does anything multiply to get 4 but add up to get 2? Well, 2 times 2 is 4, but 2 plus 2 is 4. And 4 times 1 is 4, but 4 plus 1 is 5, so no. So guess what formula we have to use? We have to use the quadratic formula to solve this. Quad formula. And hopefully you guys recall, negative b plus or minus the square root b squared minus 4ac all over 2a. So I'm going to bring this down. Plus 2x plus 4, and we are going to plug this in. Okay, so first off, my a is equal to 1, b is equal to 2, and c equals 4. They just kind of go in order here, 1, 2, and 4. Okay, so let's plug it in. Negative b, negative 2, plus or minus the square root of 4, that's b squared, minus 4 times a, which is 1, times c, which is 4. So 4 minus 16. Okay, I'm doing a little bit of a shortcut here because we've worked with the quadratic formula, right? So, again, b squared is 4, 2 squared is 4, minus 4 times 1 times 4, so it's minus 16, all over 2a, or just 2. Alright, so we have a little bit of reducing to do. Okay, so let's start with the terms out in front. We can just basically say that this is negative 1, right? So negative 1 plus or minus the square root of 4 minus 16. Let's look under the radical now. Here's where we are going to kind of remember what we do when we have imaginary numbers, right? That was a couple chapters ago. So we have negative 1 plus or minus the square root of negative 12. What do we do when something's negative under the square root? We take that negative out and put an I out in front, right? Negative 1 plus or minus I root 12 We're not quite done yet though, right? This can be reduced. The root 12 can be reduced. So we worked on simplifying radicals. Here's where it comes into play. What are your factors? I have a 4 and a 3. Here's my perfect square. So it's like saying the square root of 4 times the square root of 3. Well, the square root of 4 is 2. That can be taken out. So our final answer is -1 plus or minus 2I root 3. Alright, so our solutions, again, to this are 2, x equals 2. And then we plugged in the quadratic formula. Here are other two solutions because we have a plus and a minus. And we're done. Okay, let's do one more like that. Let's see, 27x cubed plus 1. Alright, so we're going to find all of the complex roots here. Again, using our sum and difference formula, and then we'll probably have to use the quadratic formula as well. So we're finding the sum of these two things. So the first thing I need to do is find out what A and B are. So A is my first term. So ask yourself, what is the cube root of 27x cubed? And B is my second term. What is the cube root of 1? Alright. So we come back up here. What times what times what gives you 27? Okay. 3 times 3 times 3, right? So we have a 3, and now we have x cubed, the cube root of x cubed. That kind of erases itself, right? It's the opposite operation, so we just have a 3x. And the cube root of 1, basically ask yourself what times what times what equals 1. Well, that's 1. So I have my A and B terms, and we can look on our previous slide. Here's our nice little formula guide. We're going to use the first one. So A plus B times the quantity A squared minus AB plus B squared. So let's plug those values in. Let's see, A plus B. So we have 3x plus 1 times the quantity A squared minus AB, 3x squared minus AB, and plus B squared, just double checking, yes, which is just plus 1. Okay, so we have to do a little bit of math here before we can start solving. Notice the A squared is 3x squared. Well, remembering from our exponents, our rules for exponents, that square applies to both terms, both the 3 and the x. So I'm going to start rewriting this a little bit. My first quantity is just 3x plus 1. And now we have 9x squared minus 3x plus 1. Okay, remember we're solving, so we're going to set those things equal to 0. Here's my first quantity, I guess, and it can't be reduced any further. So we have 3x plus 1 equals 0, 3x equals -1, x equals -1/3. So here's one solution. Alright, so there's one solution, and let's take a look. Now we need to see if this factors. I don't believe it does. It definitely doesn't. So guess what? Yay, we use the quadratic formula. I'm going to kind of offset this. So we have -b plus or minus the square root of b squared minus 4ac all over 2a. And now let's plug in what we know. So b is a -3 already. So a -b will get rid of that negative. So it's a +3 plus or minus b squared, -3 squared is 9, minus 4 times 9 times 1 all over 2a. 2 times a is 18. Alright, we have a little bit of reducing to do here. 3 plus or minus the square root of 9 minus 36, which is a negative 27. Okay, let me check my math. 9 minus 36, yeah. Negative 27, so we are going to have that imaginary root under the radical. And again, this is all over 18. Guess what? This can reduce first. So this 3/18, that can just be 1 plus or minus the square root of negative 27 all over 6, right? 3 divided by 3 is 1. 18 divided by 3 is 6. Moving on. Here's my negative. I want to take that out of the radical. So we have 1 plus or minus I root 27 all over 6. And my 27 can factor. That's 9 and 3. Here is your perfect square, which can be taken out. So our final answer will be 1 plus or minus 3I root 27 all over 6. And I'm okay. This form for a final answer is okay by me. So we have 1 solution, 2 solutions, and remember that third one way up here, 3 solutions. All right, thanks for watching.